National 5 Maths, Practice Paper D, Paper 1. Question 1. We've defined the gradient of the straight line joining the 2 points. So if we label them up, x1, y1, x2 and y2, we can apply the gradient formula. So the gradient is y2 minus y1 over x2 minus x1. It's going to be 3 minus -7 divided by -5 minus 3. That's going to give you a plus over -8. So we have 10 over -8, and that just simplifies to -5 over 4. Question 2, we've got to work out 2/5 of 3.5 plus 4 over 5. Now of, when it comes to fractions, just means times, so we're going to multiply these things together and then add the 4/5. So I'm going to change 3.5 to 7 over 2. Plus 4/5. So we'll work this bit out here first. So when you're multiplying those together, you just multiply the numerators, giving us 14. 5 2s are 10. And we've got to add 4/5. So I'm just going to leave the first fraction as it is. I'm going to multiply the second fraction by 2, top and bottom, giving me 8 over 10. And that gives me 22 over 10. And simplifying that, both in the 2 times table, so that's going to be 11 over 5. You can also say 5 goes into 11 twice, with 1 left over. You'd be fine leaving it as an improper fraction or a mixed number is fine. Question 3, find the equation of the straight line AB. We can pick any 2 coordinates on the straight line in order to do this. So I'm going to pick this first one here, which is 0, 1. I'm going to pick 2, 5. As I say, you could pick any coordinates on the line. I could have picked, for example, 3, 7 or 4, 9. All of those would have worked. Now, I need to find the gradient of the line. So x1, y1, x2, y2. So gradient is going to be 5 minus 1 over 2 minus 0. That's 4 over 2, and that's equal to 2. Now we can pick either one of the points, call it AB. Doesn't make any difference which one you pick. And we're going to use the formula y minus b equals mx minus a. So I'll substitute my a in and my b. So b is 1, my gradient there is 2, and a is a 0 there. Multiplying out the brackets, 2 times 0 is 0, so just going to leave that off. Add 1 to both sides, and we get y equals 2x plus 1. So it's in the form of y equals mx plus c. In this particular example, we didn't have to do the equation there. We could have just used y equals mx plus c straight away, because we know the gradient is 2, and we know we can see the y-intercept is 1. So that's just 1. So we just get y equals 2x plus 1. That only works if you already know what the y-intercept is. Otherwise, you must use that equation.